Awesome. Welcome everyone to Tiers, Tabs, and Terrible File Names, a survivor's guide to organizing your data. It's me. I am the survivor and I have stories to share and lessons and tips and tricks. I'm Annalise Eber. I'm the Research Data Management Librarian at the University of Waterloo. And this will be kind of an overview for organizing your data and kind of quick and easy tricks for people at all different stages of their research that you can implement really easily. So kind of those easy things that people are looking to do. And just a couple housekeeping things. Like I mentioned, we're going to be recording this session. The recording and the slides will be sent out to anyone who's registered after the event. We should have those out within a week or so, but also please feel free to reach out with questions in the meantime if you have any questions about the event. Please feel free to use the chat and pop any questions in there as we go. We can answer them as we go, depending on time, but there will be time for Q&A at the end, so please don't hesitate to use that. I also have my colleagues Alyssa Rusi and Antonio Munoz with me here today, so if you have any issues with the recording or need any support, please feel free to message one of them on Zoom, and they're happy to help support you. But without further ado, we can jump into things. So just a quick agenda on what we're planning to do today. So I like to start with what not to do, and we have kind of a hall of shame of examples that I've pulled from various different people I know with their permission of what not to do, and then the bit broader effects of poor data management, so we can kind of look at how it affects people outside of just ourselves as well. And then kind of chat about what is research data management, what is it as a practice, and why do we do it? Why is it important? Kind of that broader piece there, and then jump into some practical data organization for busy people. I recognize that we're all busy, and one of the hardest aspects of data management is finding time to do it. It's so easy to kind of dump files in a folder on your desktop or in your documents folder and say, I'm going to remember this, or I'm going to do this later. So having those kind of practical pieces for busy people, I think, is really important. And we'll also talk about some data management for kind of working with group projects throughout. It's not a specific section, but I'll highlight some things throughout and how we can kind of do data management for those group projects, because it does get a little bit more difficult the more people you involve in a project. And then just some wrap up and Q&A. And this workshop is part of our data journey series, which helps highlight some of the various different data skills, which are all entangled together. We've kind of started calling it a web of data skills, because it's really hard to disentangle them from one another. So this workshop's going to look at kind of planning, obtaining, and describing data and how we do that throughout the process. But you'll see little bits that come in of kind of evaluating and cleaning data, storing data, that kind of trickle into these various different aspects of these other skills that people have when they work with data. So you'll really start to see that these are really all entangled together. And even though we often divide them into separate skills when we work with data, they're really all tangled together. It's hard to kind of draw a line where one becomes the other. So we'll start with what not to do if my slide changes. Perfect. So we have the file name Hall of Shame here. And yes, some of these are file names that I've pulled from my own previous research, pre-data management librarian days. And if I knew now if I knew then what I knew now, I would have done things substantially differently. Some of these are also pulled from examples of other folks who donated their file names to the cause for this, to kind of highlight the different ways that people might name their files that seem really great at the time, maybe aren't great later down the road, or maybe aren't really great to start. So you have one on the right that's plots for Monday. What's special about Monday? It was a June 20th, but when you look at the folders, the files in there, there's no kind of real reason for those to be in there, and no kind of indication of what are plots for Monday? What is special about a Monday? Or you have one that's called a folder for important papers. What is an important paper? Why is it important? With below some sort of code that I can read what a PDF is, but what does the rest of the code mean? And when other people are looking at our file names, can they decipher what it is? You'll see there kind of in the middle, there's a really long, kind of tall one where there's M2s and other codes in there. And this is a really good example of something that is from my own research where I have those codes documented and I know what they are, but anyone else on my research team would look at that and not have any idea what that means unless I shared that data dictionary with them of the file names, which I have not. They might be able to decipher it, but that's a really good example of how sometimes we create file names that will work for ourselves, but not consider who else is going to be looking at that data and how do we make it findable for other folks. And then some other examples of things just being separated by a hyphen. So having basically two folders with the same name, and where do you save it? Or saving things with ambiguous file names like panda thumbs. It's probably a paper about panda thumbs, but what paper? Why is that important? And sometimes we have these little reminders to ourselves that we name things by so we can think about them. But if someone else is looking at that data, or 5-10 years down the road, you're looking for a paper, are you going to remember what you named it that way? So this is kind of a little bit of a hall of shame of what not to do and what we're not looking for in a file name. And some of these could be improved really easily or by just communicating what the file names mean. But in and of themselves, they are challenging file names to work with. My slide, perfect. And then we also have examples of things that result from poor data management in the wild. And I do want to acknowledge here that there are a lot of examples of kind of data fraud or data falsification and fabrication here. And not all of those result from poor data management to start. Some of them are, yes, intentional. But when we think about what are the benefits of data management, we can also think of them as being kind of proof of not creating data, not doing frauds, and being able to prove that you didn't commit data fraud or falsify any data because you can prove that you have the original data that people can go back and look at. So when you look at a lot of retractions in papers, you'll often see things like the original data couldn't be found, or there was questionable things in the raw data. And if we do manage our data and we're able to track it and kind of see that history and the log of what we've done with our data throughout the time, then we can say, here's everything I have. And it makes that investigation process a little bit easier, but it's also much easier to just see what happened throughout and to prove that there was nothing happening and they might just be very real results. And yeah, in the comments, the data appears just 10% of the time. So what you see a lot is that the data was requested, but authors couldn't provide the original data anymore. So we see issues with data not being housed long-term, or papers are out there, there's the data for it is gone, people have retired, people have left institutions, and how do you get that data then to prove what is said in a paper is true? And that becomes really important when we start looking at the scientific enterprise and the research enterprise as it is today, being able to have those verifiable results and really uphold the integrity of science there. So we'll get into talking about RDM a little. So what is research data management anyways? And it kind of seems like a no-brainer, managing of research data, but really it's how we manage research data throughout the entire life cycle of a research project, from the very beginning before you even start doing anything to the end. So it's organizing, maintaining, and archiving research data throughout the project's lifespan. And it's really easy to think about projects as kind of when you start collecting data to when you publish the research paper, and then that project is done. And that's how I find a lot of folks that I've worked with myself and other people think about research projects, is that the research paper is the ultimate output, and then a project might be wrapped up. There might be other papers that go out about it, but ultimately that's kind of the beginning and end of the research project. But when we think about data management, we think more broadly than that about the lifespan of a research project beyond the papers. What happens to the data after that? What if people need to access it? What if people are trying to reproduce something or use the data for something else? How can we make sure that that data is available long-term and findable, not only for ourselves, but for other people as well? So really, research data management is all of the processes that you use to create organized and document your data and create accessible data and reusable data. And this really leads to quality research data as we move through this, because we've now documented things and creating this kind of paper trail of what's happened to the data as we go. It's not just kind of, here's one spreadsheet and then we did something and here's another spreadsheet, but in a year down the road, I don't know what the difference between the A and B is because I didn't document what happened there. So we think about research data management as a full life cycle. So it goes from planning to collecting, processing, analyzing, preserving, sharing, and reusing. And this is really similar to the data skills web, but there's a lot of skills that go into each one of these. Data collecting itself isn't a single skill. There's lots of skills that go into that. And there's lots of ways to manage your data as you collect it and as you process it or plan for it. There's a lot of ways that people might do things differently. It's not a one size fits all approach. And that's what's really nice about research data management is kind of a principle, is that it's a series of ideas and a collection of practices that you can apply, but not everyone is going to apply to every project, and every discipline might have different ways of doing things. And it's really about finding what works for your project and what works for your discipline as well. So why do we even want to organize files? And one of the big reasons is to know what's in your files. I know just from kind of looking at those file names previously, it's really hard to tell what's in some of those files or what's in some of those folders. And this ultimately wastes a lot of time trying to decipher what's in folders or files without having to open every single file, especially spreadsheets or files that take longer to load. Having to open every single one to figure out what's in it, or kind of remind yourself what happens to that data, what does this represent, especially if there's no documentation within a spreadsheet. There's a lot of time that goes into kind of jogging your memory to figure out what happened, what's there, and thinking about how you've organized things in the past and trying to reflect back on your previous self of, why did I put this here? Why did I put these two files together? Especially if there's no immediate connection between the two. Or if you have folders that are named really similarly. I know this is something that I had done in my past just because of running out of time. So folders were named quick and dirty. I would just add kind of like, this is the new folder for this, and this has the new files in it. But now going back to things that were research data that I created and collected 5+ years ago, I look at some of those folders, and while it takes me a while to remember what does new mean, and I know just from kind of my chicken scratch documentation I have along the way that that's what I should be using, there's no real rhyme or reason to what new means there. And you see the same thing when you see like the final version of something, or the final version of something, or final version 3. Which is the actual final one, and how do we decipher between those things when we haven't created clear file names to identify them? And this is really helpful for easily finding and submitting the correct files for assignments, publications, and various other things. I've talked to lots of folks who have accidentally submitted the wrong file for a class assignment. Even into grad school, people will say, I accidentally submitted the wrong file. Can I resubmit this? And sometimes people are really great about that. And sometimes people are not as great. So being able to have a method where we can be really confident that we're submitting the right file and that we've named everything, so there's no confusion about what we're submitting. And even into submitting publications, sometimes people will submit the incorrect version of a paper for publication, and then this creates problems in the publication process and that kind of backlog there. So if we can be really sure that we're naming things so we very clearly know what is what and what should be going where, that makes our lives a lot easier and also saves time. And it may seem like a couple seconds here or there, a couple minutes here and there, but that time really does add up. And if we can create a method of not spending that time doing those things, it makes things just quicker in the long run, a little bit more efficient, and a little bit less frustrating. I know lots of people, and myself included, are often frustrated by looking through files that they know they created themselves and should, in theory, remember what's in them. What am I doing here? How do I find what I'm looking for? And it can be really frustrating to kind of go through your own work and try and find things when you know in hindsight that you could have done something differently. It's also easier to share files with others if you've named them. I know I do a lot of collaborative work in my own research lab, but also here as librarian at the University of Waterloo, where I'm sharing files back and forth with people. And quite frequently, people will share things with me and say, "Oops, that's the wrong version. Give me a second to find the other one." Or I'll be looking through files, and shared folders will sometimes have collaborative work in there, but you can see who named the files because we use several different naming conventions. And sometimes this is okay, but sometimes it's kind of hard to figure out, well, what did this person put in here? And what do these acronyms mean if we didn't have this discussion? So this is one of the good ways of working kind of collaboratively, is having these discussions about how are we going to organize our data as a group ahead of time can save a lot of headache down the road. And especially as when you're working in bigger labs or groups where there's more than one person or more than two people who are contributing to a corpus of information, it's really important to have those conversations early about how are we going to organize the data and what's going to happen to the data after the fact, so people aren't wasting time kind of emailing back and forth asking for different files or trying to find things that might be right there, but they just can't identify without having to open every single file to see what's in it. Again, spending a lot of time to do so. It's also a way to be a responsible researcher. Research data management is increasingly seen as a signifier of research excellence. And as we saw with kind of the effects of poor data management in the wild, there's a lot of accusations of fraud, and some of them may or may not be intentional. So if we can record our data and record what we've done with the data and manage it appropriately, it's a really good way to contribute to that that integrity of research itself, and really make sure that we're doing the best work that we can as scientists and researchers, so that people down the road can trust that the work we've done is exactly what we say it is. They can have trust in that research itself. And also, to just avoid the file name hall of shame, I would love if I hadn't made some of those file names and I wouldn't have had to include them in this. But when I look at those, I think they're really great examples of, if I'd been able to have this type of knowledge when I started grad school or even into undergrad, because some of those file name conventions that I had created for myself, I had done in undergrad and then carried on through grad school, because it was a lot of work to then have to go back and change everything. So if we can start early, it really makes that process of managing the data a little bit less cumbersome and less overwhelming if you start early and just take a little bit of time here and there at the end of each day or the end of each week to start managing the data, so that you don't have to do it all at once, because it becomes so much more overwhelming when you're looking at thousands of files that you now have to decide how to name. And sure, there's batch renaming things, but that still is overwhelming more than, okay, I have a couple files here and there, I can sort these 10 or so files and then it's done. Kind of like cleaning your house, where you might feel better after when it's tidy. It's the same with kind of cleaning my desktop for me. But there's also a lot of benefits of RDM, and we kind of group them into three big categories here. So there's workflow efficiencies, your academic reputation, and then also contributions to the research community. And for workflow efficiency, saves time long term. We've kind of talked about how you do that by, it's easier to find files and you have organized data. And when things are organized, they're just much easier to sort through and kind of find what you need quickly. Your academic reputation, so it signifies research excellence. There's lots of pushes around the world kind of looking at what is the value of research data as an output other than just research papers. So we're really starting to see this push for publishing and depositing research data, and how that can be a really great benefit for the entire research community, but yourself as a researcher as well. And through that, we also see things like increased citations and your visibility and recognition of your scholarly work. So when you deposit your data, you will often get another persistent identifier, or people are often familiar with a DOI. So you can get a DOI for your data, and then people can cite that data itself as well. And that kind of creates that paper trail of how people are using data when they reuse things or analyze things in future papers. They're able to cite the data that you published, and then you get that for your academic record as well. So it's both an increase in your citations, but also just of your scholarly work. You put a lot of work into the data, and collecting, organizing, analyzing the data and everything is a huge part of the research process. So if you're able to get credit for that and kind of that recognition for this background piece of research that people often kind of don't look at. I think that's really valuable there. It also contributes to better research replicability. There's lots of studies out there that show that many people can't even reproduce their own data or their own research. They have all the data, they have everything, they were the ones who did it originally, but because things weren't documented or things are missing or they don't know what is what, they're just not able to reproduce or replicate their own data. And this is even further exacerbated when we look at people trying to reproduce or replicate other people's research. If they don't even have the documentation themselves and they only have what was published or what they can find published, it becomes even harder to reproduce the data. And then we run into issues of kind of questioning the science and the research behind things when we can't reproduce those results. And science is an iterative process and research is iterative. So the goal is always to be able to kind of reproduce things, to test them, to see if they're correct, and kind of work collaboratively as community to kind of put out really reliable research. And you can't do that if you can't reproduce the research itself. We also see long-term cost savings. If we think about how much time we spend looking for things or moving things around in organizing or trying to sift through unorganized data, ultimately that time does equate to money, but also we see things like maybe you're paying for twice as much data storage as you need to because you have duplicated files everywhere that you don't need. So there's a lot of ways that we can see this kind of long-term cost savings, and it really does add up over time. And then also increased data integrity, which kind of goes along with research replicability. We want to really signify that the research that we have is good and the data is good, and you want to be able people to trust in that research. And part of that trust process is being able to be transparent about how you got that data, how you created it, collected it, analyzed it, evaluated, and being as transparent as possible. And that transparency creates this integrity of the data, and it creates that trust in the data that you can be sure that what people are putting out there is true. So kind of going along with that, the goal is to create fair data for yourself and others. And when we talk about fair data, we often talk about data being findable, accessible, interoperable, and reusable. And we talk about that in the sense that it should be these things for the community so other people can find your data. It's accessible to other people, interoperable for others, and reusable for other people. But I think there's value in creating fair data for yourself as well. It's great if data can be findable for other people, but for it to be findable for other people, you also have to be able to find it yourself. And same with being able to access it or being able to open it in various different programs. I know I have projects that I've worked on where I have uncommon file types that are only be opened in super specific programs that are created by an anthropologist back in the 90s. And if something happens to that program, I don't know what I would do because I do a lot of things in there. So being able to save things in these interoperable formats. So even if I keep that proprietary file type that I prefer to work with in this program, I can open it in something else too. And I'd have to learn something else, but it's still functional that way. And that way I haven't lost that data itself. So to create fair data, we want to avoid unknown acronyms. And acronyms are okay, but just document what they mean or use well-known acronyms. I know I will often create kind of project acronyms for the series, Data Journeys. We often shorten it to DJ. And between the group of people who talk about it a lot, we know what that means. But if we use it in our regular kind of everyday lives, people will think that we mean kind of like your traditional music DJ. So kind of those things, think about who your audience is and who else might be using that data and create file names and organize your data. So it's going to be readable by others and not just you. And also avoid unexplained missing values. This is a big one, especially with quantitative data. If you're looking through your research and you find a spreadsheet and you look and say, I don't know why this file or why this value is missing. So creating some sort of paper trail of why values might be missing. Are you missing a sample or was it corrupt? Was there an issue with it? And there's nothing inherently bad about having missing values, but documenting and being transparent about why those values are missing is really important for not only yourself, but when you go to publish data or when you go to publish a paper and say, hey, this is my raw data, and you can identify in the paper and say, these values are missing because of X, Y, Z, and you have that documentation in that paper trail that shows that they had always been missing and have documented why. You're being transparent about why you're missing values or why something might look weird, um, tucking it under the carpet and pretending it doesn't exist. And then we kind of lose that transparency bit. So if we can be as transparent as possible about that process, it makes things a lot easier. And being able to open file types, ideally in different programs, I kind of mentioned this already. It's really common in other programs like MATLAB, which produces proprietary file types. So being able to save things out in other files, but really just considering what programs do you use to do your work, and are they licensed programs? Do you do a lot of work in kind of ArcGIS, which is an expensive license? Will you always have that license? Or thinking proactively about exporting things in different file types so you can open it down the road, even if you're no longer at an institution and have expensive licenses, you can open it down the road and open source software and still work with that data, and it's not lost because you can't open the file type. And the goal is to be able to reuse data and reproduce results, whether they're your own or someone else's. The goal is that we want to be able to reproduce what we have and also reuse it. You might think of something that you have data for already that you can reuse for another project down the road, and then you can reuse it if you have it all documented. And when you go to publish something on that, you can say, hey, I have all of this documented. It's from a while ago, but I created this data. And you have that paper trail talking about what happened with the data and walking through all of that there. But now into some practical data organization for busy people. And I know we're all busy, so these will hopefully be helpful to people. So creating a folder structure and sticking to it as much as possible, and creating that folder structure early rather than kind of like ad hoc as you go. Naming files well, or as well as you can, and thinking about that process ahead of time, and even just giving some thought to what you name your files rather than kind of naming them as you go and naming them whatever comes to mind at the time, or something random that will trigger your memory later down the road. Yeah, that's a great example of softwares with bulk rename may help with this. And that's really helpful for people who have the technical skills to do that and have a lot to kind of go back and do. I find those types of things really helpful. And if we can keep it up as we go, then we can avoid having to use kind of those bulk renaming ones or having to kind of figure out the structure as we go. But it's never too late to make that structure, and there are tools to help kind of organize things from past research. Versioning numbers numerically, avoiding the classic final, and whatnot, and keeping track of how you're going to version them numerically. Are you using leading zeros, and just something that makes sense to you and whoever you're working with as well, and just making sure that that's documented somewhere. It can be a simple blank text note where you've just kind of written down how you've named things so people can see that and they can figure things out with that. Cleaning up unsorted files regularly. I know I can be really bad sometimes for just kind of creating a pile of files on my computer somewhere and then saying, I'm going to go organize these at the end of the week. And then the end of the week comes, I don't have any time for it. So I'm going to do it at the end of next week. And then sometimes it builds up. So do as I say, not as I do sometimes. And there are always going to be times where we fall behind in our data management, but really making that effort to try and keep up with things makes it a lot easier. So having a file structure, even if you have that pile of documents on your desktop, you can then go sort them pretty easily later down the road and kind of rename things if you have them. But even just kind of that smaller pile of documents is less overwhelming than having to do it from scratch after you have years and years of research. Backing up your files is really, really important. I've seen so many people who have lost their data because their computer was stolen, or something happened to their laptop, or they left the university and their data was on their OneDrive. So backing up the data is so incredibly important. Keep copies in more than one location, and then you'll have that copy if something happens down the road. And there are way too many examples of how people have lost their data to kind of summarize here, but I promise no one wants to lose their data. It makes life so hard, and all of that important research that you've done and all of the time you've put into that, if we can just back things up as we go, that makes things a lot easier. And having regular backup schedules or a regular system for moving things to a backup system as well. So you do have that copy of the data, or if something happens to a file, it accidentally gets deleted, things happen, then you can still go back to that as well. It's not just kind of for these emergencies or these disasters. It can be really helpful for kind of, oh, I wonder what like a previous version of this data looks like, or I wonder what I did here, what this raw data looks like. And then you can go back to that as well. And document everything as much as possible. Write it down, whether it's in a text note, an Excel file, a Word document, if you put it, even if you put it on a piece of paper and you're planning to put it online somewhere else, but documenting it so people can find things, yourself included. And keeping that documentation with the data as well is really important. So people don't have to kind of find the documentation elsewhere and then go find the data. Keeping everything all together is really helpful. So keeping kind of like a README file at the top of your folder structure. So you go into the first folder, there's a README file that describes how you search through that folder, what everything includes, the file naming structure, the file versioning, maybe where things are backed up to. That makes life a lot easier. So documenting not only your methods of what you do for your research, but your methods of how you've organized your research is helpful. And some tips for creating a folder structure. There's no one single way to create a folder structure, and I have included some resources at the end to tools that will help create this or help work through how to create this. But I like to think about what is the most important information that you need for finding the files? Is it the year? Is it a funder? Is it a research lab? Or if you're a principal investigator, is it a student? If you have students who you supervise, what do you want to find things by at the top level? And then are there existing structures that you use, whether it's an employee or an employer structure or a field structure? Are there standards that you need to use? Sometimes labs will have kind of this structure in place and you just have to kind of fit your data into that structure. So thinking about that from the beginning is really helpful. I know in my own experience, we've had folders per student. So in grad school, we had a folder for each of us as students, and then all of our data was in there. But within those folders, it was kind of all over the place. So we would have really benefited sometimes from having kind of that more consistent structure. And I wish I had done a better structure then so I could find things now much further down the road. And thinking about what information do you need to group together? So not only what information do you find the most important for finding files, but how do you want to group things together? And this is where I find it gets tricky when you're trying to clump information together or files together, because there's no single way to do it. And that's again where you kind of think about, well, what's important? What is common between these files, and how would I intuitively go to find these things? And you might find that something might fit in two places, and sometimes you just have to decide which it's going to go into, and that's okay. But really thinking about how you're grouping information together so the way things are clustered together makes sense. And thinking about what type of information are you organizing? Are you doing personal data, kind of finances or medical data? Are you organizing research or coursework? This is all going to impact how you create that folder structure and how you organize your data from there. And there's lots of ways to do this, and I have a couple examples on the next slide, but really thinking about what are you organizing and being intentional about that. So I have a couple examples here, and this one starts with a research project, and then you have experiment A, experiment B. And ideally, in a perfect world, everything under each experiment would be the same. I've included two different kind of hierarchies here as an example, but it doesn't mean that they should always be different. It's kind of what works for you, what works for your lab, what works for the people you're working with, and what you think will be most helpful down the road. Sometimes people will separate things by experiment A or experiment B or what have you, whatever you call it. It might be analysis or something, and then you'll have your data and then subfolders for raw data and process data, so you can easily find that. And then your analyses in a separate folder with different types of analyses folded under that. And then you might have your scripts. If you're doing anything with programming language, you might have a separate folder for scripts that exists somewhere. And this isn't to say that this is the only way to organize kind of research data that way, but just an example to kind of get you thinking about how would I divide up my data? What is a logical way to do that? And then under experiment B, I've kind of included a different version that I've seen in the past that's helpful, where your data, your raw data, your process data, but then sometimes results rather than analysis. It depends on the type of research you're doing, where you have figures in a separate folder and then maybe papers. And then again, scripts in a different folder if you're working with any programming language. And it really depends on the type of research you're doing for, do you keep analyses together? Do you put results together? How do you group those things together? And this, I think, is where people will start to see that it's hard to decide how to group that information together in a logical way that makes sense for as many people as possible. There's no one right way, but there might be a way that's easier for you. And then some examples of kind of non-research data. Some people will start with the date. I know I've used date in the past where I'll have a folder for each semester, fall 2025, winter 2025. And this is really helpful if you're doing things like coursework and then can divide by course number and then assignments, readings, and break it down from there. And I've found that really helpful in the past, but maybe that doesn't work for everyone. And it probably doesn't work if you're doing something that isn't divided by semesters. So again, thinking about what is the purpose of how you're organizing your data? And then you might have things divided by topics. So you might have a folder for your finances and then subfolder by year, and then a separate folder by medical stuff, and then a separate folder for coursework, sorry. It really depends on the type of information you're sorting and what is all together with it. So really just being intentional about how do we organize our data and giving some thought to it, because I'm sure that not everyone gives thought to these things until it's already a mess, especially with our personal data that we keep on our laptop that might not be counted as research data. And then for file naming, I've seen lots of things in the chats about file names. There's obviously no right or wrong way to do this. There's lots of tips for how to do it, and there's some links at the end for resources for creating file names and working through that process as well. But the goal is to create descriptive file names that you're going to know what they mean. So it should be both human and machine readable. And this is where we kind of get into that. How do we bulk name things if it's not machine readable? Because it goes through and looks for those strings of text to bulk rename them. But if we haven't done that in the past, or have kind of just named things randomly, or if there's nothing consistent between files that we would use to bulk rename them, that's where it gets tricky. Something might be human readable, but not machine readable. So the goal is for them to be both. And you want to use short and unique identifiers. And this is where creating acronyms comes in. It's okay to create acronyms, but just document what they are or make sure they're very obvious. So something is unique to a project that you want to use in the file names, but it's not too unique that you're never going to remember what it is either. And follow common naming conventions. There's a couple examples here of camel case, snake case, kebab case. There are other examples, and there are other variations of these names, but something similar that makes this machine readable while still being readable to humans, if not a little bit more difficult than kind of space, words divided by spaces that way. And using underscores instead of, or hyphens instead of capitals, or using underscores, hyphens, or capitals instead of spaces. That really helps as well for that machine readability piece. I know I typically use a combination of camel case and snake case, but work really closely with people who prefer kebab case. So you can always see who's named files based on the case we use. And then for file names, things to include are the file topic or a project acronym, things like a project name or an experiment or important information that will help you think about what's in that file. The date, ideally in a standardized format. I'm sure we've all experienced looking at something and saying, is this month, day, year, or a day, month, year? So including something in a standardized format and ideally documenting that format somewhere else. The file version, and maybe your initials if you need to. There's lots of cases where people might not need to include their initials, but really thinking about what is important for this file name. So in the case here of file naming in the includes, not everything might need to be included. You might not need your initials. It might not need a version, but these are some of the things to think about including in your file names. And the don't includes special characters. Oftentimes computers will not let you use the special characters, but just avoid them altogether. The word final anywhere in a version number or your file name. Do not use the word final anywhere, if at all possible, unless it's part of kind of your project's name. And things you're not going to remember or haven't written down the meaning of. This is a really big, important one, where people will create acronyms or short forms that you have for a project that maybe down the road you don't remember, or they're short form for a part of a project or like a hyper specific subset of that project. And if you're not going to remember it down the road, that makes the file name much less useful. File versioning can pretty much be summed up into numbering your files numerically rather than data management files, something like data management version 3.0 or 3.0 if you use the leading zeros, rather than doing this. I see a lot of final drafts or final drafts or any number of finals, and I've seen this both for people in various different stages of their academic careers, but also people who work in large corporate offices. I've seen lots of final versions of something, and how do you know if version 20 is the last one or which final? How do you figure that out? And then backup and storage. The goal is to keep 3 copies of your data on 2 different media types and keep 1 copy offsite. So this could be 1 copy on your computer and 1 copy in the cloud, or it could be 1 paper copy depending on the research. But really just thinking about where are you going to back up your data so you can access it. And this is really important so you don't lose your data, but just making sure that you have that backup available to you. For documenting your data, things that you're going to want to do is documenting your file naming conventions, file versioning conventions, the variables and the formats, and descriptive information about each variables, their consistent values, and their unique identifiers. So you can see on the right an example of a data dictionary that we've made for just a random project that we're doing. So you can see that we've identified the date standard there and the year, month, day. So we always know that when we look at a file name, or when we look at the data there, that the date is in the year, month, day version. But we've also included things like what the values mean or what we're expecting, whether you're expecting an integer or a date, or you could have something like a string or text characters or whatnot. So including what you're expecting to see there is a really great way to organize your data so that when you look at it, you know what you're expecting. Are you expecting an integer between certain values? So documenting that also helps you identify later down the road values that shouldn't be there. And just for documentation types, you've probably seen a number of different types. 2 really common ones are README files and data dictionaries. So I tend to think about README files as kind of a project level documentation for like those big project things, but they can definitely be smaller than just project based. And data dictionaries is kind of this variable level documentation. And in README files, I often will include author information, data collection and methods information, so that's all together as well. The software information, including the version of the software, file naming and versioning details. So when I look at a project in the future, I know how I name things in the versioning, as well as the relationship between files. I know often for the work I do, I will have 2 different files with the same name in different file types because they do different things in a program. So they have the same name with different file extensions. So I know that those 2 files go together, and say a CSV file goes with a specific Word doc or whatnot, so they can match that way. And documenting that relationship can be really important, as well as any related publications, especially if you're creating a README for depositing your data, for example. Creating something that has all of this data together is really helpful. And then data dictionaries, things like the data type, whether you're expecting a string, a number, integer, or a date, and what those should be. The date or the data format, whether you're expecting a character or a specific thing. In this case, we've used date as an example, so we want this to be in a year, month, day version, but maybe you're looking for a format for numbers and integers and you want to say 6 decimal points. So all data should be to 6 decimal points. That would be an example of kind of documenting that format. The field name versus meaningful names. So we often see shortened forms for field names because it gets really cumbersome in Excel to have these really long field names at the top. So documenting what that meaningful name means somewhere, so you know that when you see this code or this string of text that you've used as the name, what it actually means in a meaningful sense. And maybe you don't need to, maybe they are already meaningful, but if you tend to do those shortened field names, documenting the meaningful name is really helpful. And then descriptions of the variables, so people know kind of what does this actually mean, especially for those variables that might be a little bit ambiguous or could be interpreted different ways. Documenting what you mean by those is helpful. And then expected or possible values. A common example here is if you're doing a survey and there's options of yes or no, documenting somewhere that you're expecting the word yes or no rather than yep, nope, yeah, or any variation thereof is really common. So being able to document what should be in those fields so you can standardize it and make the cleaning process easier down the road is helpful. And then just as a wrap up, save time or start early. It's going to save time in the long run. I promise. I know it always seems like it's going to be really tedious to kind of do this process as you go. And it's hard to set aside that time at the end of each day or the end of each week to do this kind of administrative work when you could be using that time to research. And it feels almost kind of, I don't want to say wasteful, but it feels hard, like, especially if you're on a roll, to stop a couple minutes early to make sure you put your files away for the day or organize anything that you've created that day. But really taking the time to do that helps everything go smoothly for as long as possible. Document as much as possible in whatever way works for you. If it's written down, you're less likely to forget, and at least you can recover that information later. Keep on top of organizing your files. It seems tedious, but a little goes a long way. If you organize a couple things here and there, or if you have a big file renaming or big file reorganization project that you're working on, doing a little bit at a time really helps things go smoother. Back up your data. If you take nothing else from this, back up your data. It's really important, and you can go back and organize things after, but if you lose your data, you have nothing to organize. And if you don't know where to start, reach out to the library. I'm always happy at Waterloo to help people think through their file naming and their folder structures, how to organize their data. And I'm sure folks who aren't from the University of Waterloo have librarians at their own institutions that would be more than happy to chat about this as well. There are people there and resources to help you, so don't ever hesitate to kind of reach out to those resources. But as a starting point, or if you want to kind of poke away at the things on your own, I've listed a couple of resources here that will be emailed out in the slides that are all hyperlinked to various resources for helping to create those file names and those different structures, especially when you don't know where to start. Some of them are really helpful for thinking through, what do I actually need to organize here?